Hello. Hello.
How are you?
How are you?
I'm good.
Um, Miss Karina, how are you doing?
I'm good.
I'm good. How are you?
So let us begin. Um, today, today we have, last week we finished the normal distribution. So today we'll begin with a new topic, which is confidence intervals. Confidence intervals. Just give me 1 minute. I want to close some food pages I opened. Okay, I think it's good now. So confidence interval will start today. Um, confidence interval. Okay, make it big. We start with confidence interval for the mean. Now, I want to make sure everybody's seeing this. Now, as you know, you have a test this week. So I already put it there, and it will cover what we did. The discrete probability distribution, binomial distribution, and the normal distribution that we completed last week. That's what the test will cover. Now, the confidence interval simply means an estimate, an estimated range of values that a population parameter can assume or can, that is likely to include the population parameter, I mean to say. So a range of values from the lower range to the upper range that will likely include an unknown population parameter. Now, when I say population parameters, like I explained at the beginning of this class, population parameters, let me write it down. I'm sure you must have remembered, but this part usually confuse some students. When I ask them what is a population parameter, they think that it is something big. It is not. As a matter of fact, the population parameters include the mean, things like mean, which is like population mean, which is mu, and then things like standard deviation, deviations, which we use the symbol delta for, and things like even proportion, like percentages, proportion, P. All these things are the population parameters. We try to estimate them or get an estimate of what they are using a sample that we have. In most cases, the only way you can know exactly what the population parameter is if you study the entire population, the whole population. Other than that, you can only have the estimate. Okay. Only Providence know exactly what the population parameter is, the value is, because most times, I'm talking about like almost 95% of the time, we are dealing with samples, not the entire population. We deal with the entire population if and only if we are ready to conduct a census. And a census is a very expensive exercise. So what we do is now is to use the samples. Okay. Now, a confidence interval gives us an estimated range range of values that is likely to contain the population parameter we are looking for. Now let's begin with some basic concepts. Some basic concepts that will help us understand this better. Now remember the table I say to the statistical table I say to print and keep it handy because we'll be using them. So now we continue to use them till the end of this semester. I'm referring to this table here that I uploaded for you in the file section. We're still going to be using table 5 and table 6 today. Last week we stopped at table 5. But for this topic, we need table 5 and table 6. Let me make it a little bit bigger. I think I have the plus sign. Okay, good. Now, back to our introduction. So the basic concepts that we need to understand this confidence interval. We'll start with the point estimate. Then we then go to the confidence interval estimate, which is our main area of the main area we're interested in. Now, point estimate to give you a single value, and that a single value estimate of the parameter. And the best point estimate for something like mean, population mean, is the sample mean. Anyway, I'll give you an example. A bus driver can say that the average price of gas is between, in 2018, is $3 34 cents a gallon. This is one number. Gas price that time might be in some places might be a little bit higher than this, or a little bit lower than this, but it's just one number. He gives an average that he gave us. Another example: Ford CEO. You all know about the Ford Motor Company. The CEO might say that, okay, the company produced on average 200,000 cars in the year 2013. Again, one number. It might be they produce a little bit higher than that or a little bit lower than that, but you give us the average. So that is the point estimate, a single number that will give us an estimate of what the population parameter will be. However, the one we are interested in is the one that we call the interval estimate. This gives us a range of values that will give us an estimate of what the population parameter will be. Now, this is more reliable than the point estimate because it gives us a range. For example, the same local bus driver can say, okay, the price of gas in 2018 is between $2 per gallon to $3 per gallon. So these values also included the $2.34 inside that range. See, so if we check the gas prices at different gas stations in that year, you see that they fall within these two range. Most of them. The same thing with the Ford CEO for the Ford Motor Company can say, okay, the company produced on average 190,000 to 250,000 cars in the year 2013. So that is the range, two values, the lower value, the upper value. So I want you to have that in mind. When we're doing confidence interval, we have looking for the lower value and the upper value. So two values, okay? Now, which brings us to what we call the confidence level. Now, the confidence level simply means the likelihood that the true population parameter, for example, the mean, lies within the range specified by the confidence interval. For example, we can say that this driver say that he is 95% sure that the average price of gas in year 2018 is between $2 and $3. See, he's 95. He's not 100% confident. Nobody is 100% confident. Only Providence can be 100% confident. And if you remember your DNA test, sometimes if you listen to some result of DNA, you say you are 99.9% not the father, or you're not 9.9% the father of this kid. So they can never tell you 100%, because like I said, only Providence can know that. You know. So the confidence level gives us how sure are we that range will contain the population parameter we are interested in. So usually you can also be 99% confident. So even 92% confidence too, 85% confidence. Now, if you look at, if you remember the COVID-19 vaccine, for example, they say the Moderna, I think the Moderna vaccine is effective 95% of the time. I forgot the exact number they used. But the Johnson & Johnson, I think their own is about 80%. I can't remember exactly. But those are the confidence level. they are 80% or 90% confident that that vaccine will be effective, you know. So that will give you an idea of what a confidence level is. But usually in statistics, this is the common confidence level we use in most of our statistics classes. We have the 90% confidence level, 95% confidence level, and 99% confidence. This one, those in the pharmaceutical industry usually, try to keep this mark, 99% confidence level, to be sure that the medication is doing what they say it should be doing. So if you get as close as you can to this level, like those pharmaceutical companies that are making a COVID-19 vaccine are trying to hit that target, then that means the medication is effective. Now, next thing we need to look at is the critical value. Critical value. Now, the critical value is, I'll call it the cutoff of value. It simply means the number at the borderline separating the statistic that are likely to occur and those that are unlikely to occur. So you just like 95, the confidence level, like this percentage give us the confidence level, but we have to interpret this level into a number that will give us a border line where, okay, we can say that if it exceeds this amount, that means it is no longer, it is still fall within 99 or 95% or 90%. I'll give you a good example. If you remember a credit score, for example, if you apply for a loan, if they check your credit score separates you from other, they have the 700 score, 600, so to have those levels. So that will give you an example of how the critical value works. It cut you off from certain different ranges. So, for example, for 90% confidence level, the critical value is 1.645 or 1.65. So anything below that is not in this critical value. No. Now, for 95%, the critical value is 1.96. Anything above this is now outside the range. Outside this is bigger than that borderline. So in testing hypothesis, we say anything bigger than the critical value, any value that is bigger than the critical value, you reject. But we will come to that. Now, notice that here we have Z alpha over 2. Now, this confidence level that I explained to you is what is the alpha we are talking about. Okay. Alpha is a significance level, but we use it here. Basically, that's what it represents here. So alpha, if they say alpha 0.10, that means they are talking about confidence level of 90%. So alpha 0.10, alpha is actually the significance level, but it have a relationship, a link to confidence level as well. If you say that the alpha is 0.10, that means 0.10 is 10%. It means that your chance of being wrong is 10%, which means that you are 90% confident. If I use alpha 0.05, which is 5%, it means that your chance of being wrong is 5%, which means that you are 95% confident. So you can see how it links to the confidence level. And each of the alpha level have a critical value attached to it. So anything above the critical value, that means it's not, I would say, not within the range we are trying we are looking for. It's bigger than the range or outside the range. If it is test of hypothesis that we are doing, if it's bigger than critical value, we will reject. So I'm going to show you how to get these critical values. If you are given the confidence level or the alpha level. So I think we can begin from there. So let us do some example of that. I call it finding critical values. Okay. There are many ways you can use, but I have a shortcut method that you can make it faster for you to get this critical value. That shortcut method involve the use of this formula. I'm going to make the formula. Let me get the formula from the, let me write it down from the other workbook. So in that case, we have critical value. We call it Z alpha over 2. We'll put that this way. Why alpha over 2? Because remember, I told you the confidence interval have two sides, the lower side and the upper side. So that's how the idea of having alpha over 2 comes into play. Now, you have alpha, which is going to be somewhere here. Just a minute, let me get alpha over 2. Okay. Critical value Z alpha over 2. So that shortcut method involves the use of this formula. P over 100, P over 200. Remember, confidence level, confidence a percentage is over 100. But because of two sides that we have, you can use P over 200 because of we're dealing with the lower side and upper side. So it is a shortcut method that we can use to find the confidence, the critical value. And you can, even for a test of hypothesis, you can use it for two tail tests. We'll come to that eventually. You understand what I mean by that. So this is give us help us to get an estimate of the critical value for when you are doing confidence interval. It will help you to get it faster. Okay. Now let us see how this works. The first example we do is number one solution. Solution. It says find the critical Z alpha over 2 corresponding to 95% confidence level. Okay. Now remember, alpha over 2 because we have two sides, left side and right side. So in that case, the formula is P over 2. Here, P is given as 95%. 95%. Which means like P over 200. Again, why 200? Because percent is over 100. But since we have two sides, this one 100, the other one 100, so about 200. Excuse me. Now, you see how this will help us to get the critical value faster. So this means 95 divided by 200. Okay, and then which give us with our calculator, Desmos calculator, we have 95 divided by 200. I see 0.475. Let me write it down. 0.4750. Okay. So we go and put it here. 0.4750. 0.4750. Why 50? Because if you remember the table, like as I showed you a few minutes ago, I'm going to show you again. All the numbers here are four digits. If you look at this one, 1, 2, 3, 4. Those are not 4 digits. You use a 0 to complete it 4 digits. This explains why, even though we have our answer here as 0.475, we write it as 0.4750. Okay. So 0.4750 is what we have from our division. Now, which means that the critical value will be so sorry, my mistake. I want to change something here. Critical value, Z, critical value Z alpha over 2, our value will now become give me 1 minute. Okay. Critical value will now become Z P over 200 which means 95 over 200, which gives us 0.4750. Now, we look for this on the table to get our critical value. So I'll take you to the table, and we have 0.4750. See, 0.475 is right here. See, and then you follow it to the left. Give me 1 minute. Let me do this. Okay. 0.4750. You follow it to the left. I get 1.9 and up 6. So that we have it as 1.96 become the critical value. Okay. 1.96. And when you go up here, you can see that I have it here for 95. You see that it is 1.96. And remember, for 95% confidence level, your chance of being wrong is 5%, which makes your alpha 5% and 0.05. Now, any question to this? Any question?
No.
Okay, let's try one more example there before we can now do example on confidence interval. So we have, it says, find the critical value for, say, find 99% confidence level, or what you call find the critical value. So in this case, P equals 99%. So that the critical value, which is here Z alpha over 2, Z alpha over 2, okay, alpha over 2 equals, change this back. Okay. The alpha over 2 becomes 99 over 200, which gives us from the calculator, we have at 99 over 200. Okay, 99 by 200. 0.495, right down 0.4950. So 0.4950. I'm going to write it as an answer there. Then we now locate it from the table. 0.4950. Now we look for it on the table. 4950. I got 4948. I got 4948. I got 4949 and 4951. Both of them are equally close. If you subtract, like I explained to you last Friday, if you subtract this from 0.4950, you get 1 point. I mean this one. So let me explain. We have two numbers, 4949, and we have the other number, which is 4951. So, but what we are looking for is 0.4950. We didn't find 0.4950 exactly. So, but we find two numbers that are close to it. One is 0.49449, which is this one here, 0.4949. In 1 minute, yep. Just 0.4949, right? This one here, and then 0.4951, which is this one. So we now check both of them, which of them is closer to it. So let us check it here. You can see from the calculator, I have 4950, 4950 minus 4949. Answer is 1. You see, it is 1 point away. Okay. Now let us check the other number that we have. 4951. So look at them as whole numbers. Minus the one we're looking for, which is 4950. 50. is 1. So you can see that both of them are 1 unit away. They are equally close. So when you have them in this form, remember, if one of them is bigger, more far away, choose the one that is closest. But now both of them are equally close. So you choose the bigger number, which is 0.4951, this one here. So now you can now follow it to the left. Excuse me. You follow it to the left, all the way to the left. See 2.5. Okay. Then you go up 8, 2.58. So the critical value becomes 2.58. 2.58. Okay. Now, when you go up here, you can see that you have it as for 99% to have is 2.575 or 2.58. How do they go to 2.575? To get that, you use 2.4941, 4949, which is 2.57, then 4951, which is 2.58. Then you add them and divide them by 2. That's the average. That will give you 2.575. But we're not doing that. We just, like I said, shortcut method. Take the bigger one. That will give you exactly 2.58. Okay. Any question on that? Any questions?
No questions.
So, but the good news is that some critical values will be given to you. Like I can show you from this table. You can see from the one I have here. But if you look at table 6 of this thing that chart, table 6. Well, not table 6. Sorry, my mistake. Table. I think it's on table 7, I believe. Let me see. Yeah, that's true here. The table doesn't have a number. You can see the critical values. 75%. This critical value is 1.15. For 80%, 1.28. For 85% is 1.44. For 90, 1.645, or I can call it 1.65. For 95% is 1.96. For 95%, sorry, for 99% it is 2.58. So it's it's there in the table. But for those of them, if the critical value is not given, then you have to calculate it by yourself using the shortcut method that I explained to you a few minutes ago. So that is the reason why I decided to explain it here. Otherwise, the critical values for 95, 99, and 90 are usually given, So with this, we are ready to do the confidence interval. The confidence interval for the mean. Let's start with the confidence interval for the mean. As we proceed on that, I wanted to remind you that the best point estimate of the population mean is the sample mean. Okay. So in this example, the first case 1, we look at case 1. Case 1 that we'll be looking at. Case 1 is the confidence interval for the mean, where the population, you can see the symbol, the standard deviation is known and the sample size is large. Statistically, we say that the sample size is large if the sample size is 30 or more. Give me 1 minute, let me turn my cell phone off. 1 minute, turn it off. Okay. We say that the sample size is large if it is 30 or more. That means n is greater than or equal to 30. And the standard deviation is known. So in that case, we estimate the confidence interval using the formula that I'm going to show you. The formula is this. Formula. The first thing you do is to find the error margin. Okay. You have the critical value. The error margin will now becomes what do I mean by the error margin? Let me show you what I mean by that. Now, if you're 90% confidence that the average is within that range, your chance of being wrong is 10%. That's the error. So, but you have to find it as a number that is not a percent. that number that is not the percent, that's we call it the error, margin of error. So if you are 95% confidence, your chance of being wrong is 5%. So you have to change that 5% to a number that will represent the error margin. So that's what I mean by the error margin. Now, so once you find the error margin, I'm going to show you the formula for that. We have the error margin is the error margin is E equals, so I'll have it this way, Z alpha over 2, which is critical value, Z alpha over 2, Z alpha over 2. Let me find where I can find alpha. Okay, over 2 times standard deviation, which is delta over the square root of n. Okay, that will give us the error margin. Okay, I'm gonna move this to a main workbook. Okay, so I'll call it the computational formulas. Then so once you have the error margin, you are basically getting your confidence interval. So the confidence interval, the interval estimate now becomes equals is now on the left side you add the error margin, on the right side, on the left side you subtract the error margin. So you subtract the answer you get from this on the left side. Then on the right side you add it. That will give you the confidence interval. So let me show you how it is written. It is written in this form: x bar minus error on the left side. Okay. It is x bar, okay, minus error is less than the mean. Okay. It's less than the mean, which is what we are trying to estimate. Okay. Less than the mean. And then it's less than the x bar plus error. X bar. Now, when we start solving this, you see that it's really simple. Okay, plus error. Let me make it bigger by moving it to our main workbook. X bar plus error. So as you can see, on the left side, you add the error margin, and on the right side, you subtract the error margin. See, you add it, on the left side, you subtract the error margin, and on the right side, you add the error margin. That will give you the confidence interval. Okay. So let us do it now. Now, it says, a sample of reading scores of 35 fifth graders has a mean of 82. And the standard deviation is 15. Find the best point estimate of the mean. Then it says, find 95% confidence interval for the reading scores of all fifth graders. Then find the 99% confidence interval for the mean scores of all fifth graders. Okay, so let's do it. Solution. A says, find the best point estimate for the mean. Well, they tell us that the mean is 82. And if you remember, I told you a few minutes ago that the best point estimate of the sample population mean is the sample mean. Here they say that for this 35 fifth graders, the sample mean is for them is 82. So if they ask us, what is the best, find the best point estimate of the mean? Of course, the answer becomes mean equals 82. See, because you say that the best point estimate of the population mean is the sample mean. So given that we are told that the mean of this sample of 35 are 82, so that will become our best point estimate. So that answered part A. Now in part B and C is where we actually do the main work of finding the confidence interval. In this part, remember we are told that the mean is 82 and the standard deviation is 15. So the mean here is 82. Mean, let me put it the way it's gonna be. Mean is 82. So you have equals 82. I'll copy it out here. And then the standard deviation mean is 82. I'll make it a little bit bigger. Okay. Now the standard deviation is population is giving us 15. So give me 1 minute. Let me put this together. Okay. The delta, which is the standard deviation, is giving us 15. Okay, you have it here as 15. This can always go back to the font size of that is small font size. I don't know why it does that. 18. Now it says, how many of them? 35 fifth graders. So n equals 35. And so I think I'm gonna move this down so that we can have enough room. Yeah. Okay. Now mean is 82. Standard deviation is 15, and sample size is 35 fifth graders. Now, you say find the 95% confidence interval. Now, I'll show you how we have to find the critical value, which is z alpha over 2, z alpha over 2, z alpha over 2, which is the critical value. And like I explained, I've shown you how to get it using a shortcut method. Now, you can apply that to this, but we have it already in the chart. It is said that for 95%, right here, the critical value is 1.96. If it doesn't have it, then you can use the method I explained it to you a few minutes ago to calculate it by yourself. But if you don't have it in the table like this, so but we have it here 1.96. So we're gonna put 1.96 for that. 1.96. Now, so next thing is to calculate the margin of error. Margin of error. Like I explained to you, the formula is here. The error margin will be, the copy it so you can see it. The error margin is, the formula is right there. Z alpha over 2 times standard deviation over square root of n. So that means, let me write it down. Z alpha over 2, we have it as 1.96. 1.96 times standard deviation of 15 over the square root of 35, which is n, which is 35. So I'm going to put it in the form of that it should be, and then come here and paste it back here. So I'll have it as the error becomes error, which is z alpha over 2. Okay. Z alpha over 2, z will have alpha over 2. What is our alpha? I think it's going to be somewhere here. Okay, right here. Over 2 equals, oh, my mistake. Error is which is E, equals Z alpha over 2, which is 1.96 times the standard deviation, which is this, 15 over the square root of n, which is square root of 35. So with this, we figure this out from the calculator. The alpha over 2 times standard deviation over n, and that will give us the confidence level, sorry, the critical the error margin that we're looking for. And then with that, we can find the confidence interval. So let us put this in the calculator and see what it will give us. Okay. The alpha over 2, like this. So 1.96 times standard deviation, which is 15 over the square root of 35. Then we close it. Like a 4.97, actually 4.9695, you keep going, but we stop at 4.97. So let me write it down. 4.97 is the error margin. So let us go and put it on the and work. 4.97. Okay. 4.97. So I'm going to copy this and then put it here. So I'll paste it right there. 4.97. So that we have now we have the error margin. We can now get our confidence interval. Now, remember that the formula is given in this form: x bar minus error less than mean less than x bar plus error. So this is the formula for the confidence interval. S bar is the mean minus error. On the left side, you add error. On the right side, on the left side, you subtract error. On the right side, you add error. So you have, so that the 95% confidence interval, 95% confidence interval is given the right formula. So we have our mean as 82. So here we have 82 minus the error, which means 82 minus 4.97. 82 minus 4.97. And less than the mean, see, less than the mean. This is the mean we are trying to estimate right here. So less than the mean, I'll have it less than the mean, okay? And of course, 2 less than, so less than the mean. And this time our mean is mu, which is what we are trying to estimate. Then less than, on the right side, you have x bar plus error, which means 82 plus 4.97. 82 plus 4.97. See? So you can see that it is the same 82 on both sides. But on the left side, you subtract the error. And on the right side, you add the error. So this will give us the 95% confidence interval for the mean for that then. Then we can now make our conclusion. So 82 minus 4.97, we have it here. 82 minus 4.97, we can use a calculator to do that. So 82 minus 4.97 is 77.03. Okay, we have here as 77.03 on the left side, 77.03 less than the mean. Okay, we have less than the mean, Okay, have it on both sides. Then on this side we have 82 plus this. So that will give us if you add them together, if you go to decimals and add them together, because it's already there in the calculator. So just change this to plus sign. Okay, plus sign. Plus 86.97. So we have 86.97 here. And that will be 86.97. So the 95% confidence interval is for the reading score. Remember, this question is about the reading scores of fifth graders. Remember, it is about the reading score of fifth graders. So we are asked to find the 95% confidence interval for the mean reading scores. And we get the interval as here at 77.03 to 86.97. In some books, they will write it in this form. They'll put the lower part of it, 77.03, and they put comma, and they write the upper part at 86.97. It's still the same thing. So let's conclude now. Last part of the work is the conclusion. Do the conclusion. Conclusion. So this is how we conclude it. We are, remember, this is 95% confidence. So we put our conclusion in this form. We can say with, make it bigger. We can say with 95% confidence. With 95% confidence that, so what are you trying to estimate? You are trying to estimate the mean, which is the average reading scores or the mean reading scores of all fifth graders. So that the average or mean reading scores for all fifth graders lies between, now if you look at our answer, it says 77.03, 77.03. I don't know whether this is percent or not, but this is the score, to the other part, which is 86.97. See, so that the average reading score for the for all fifth graders is lie between 77.03 to 86.97, based on, and we are 95% sure that that is the case. Any question on this? Any question?
No.
So now when you go home, try the part C, just use 99%. It is still the same method, except that here your critical value will be 2 point, see, for 99% is 2.57, 2.5, use 2.58. Then use it to find your error margin here, okay? Find the error margin. It is still the same mean of 82 because it's still the same question. Then the standard deviation is still 15. So that your N, which is the sample size, is still 35. So the only thing that will change is your critical value. Then use it to find your error. Then add, subtract on the left side and add on the right side to get your confidence interval. Then conclude. So do the same thing for last part C. Then when we come back to Wednesday, I will show you this example how to do this using Excel. I think that is what you have in your Excel assignment, where I give you a number and say find the confidence interval. So I'm going to show you how to do this using Excel when we come back on Wednesday, and then we can look at how to compute sample size. Okay. Before we go, does anybody have a question for me? Hello, class. Anybody have a question for me before we leave? Huh?
No questions.
Okay, hold on. Let me take down your names. 21. So we have Aaron is here. Mr. Aaron, you emailed that you work, right? Mr. Aaron. You there, Mr. Aaron?
Yeah.
You email the work I gave you?
Yeah, I'm still working on it. I can email it to you tonight.
Okay, let me have it tonight then.
Yeah.
Here. Okay, good. And Bennett here. And the Chambers is here. Nicholson. Who else? Oh, Nick is here. Nick Taylor is here. I think that's what we have here. All right. I see you guys on Wednesday.
All right.
I have a question. So would you be
Thank
able
you.
to send me anything today?
Um,
Would you be able to send me anything today?
Not really. What Aaron is saying is something different. I gave him something different on paper.
Paper?
Yeah.
Did you send it like email?
No. The Aaron is a different case. I have with Aaron. Not he doesn't have to worry about that.
Okay.
Not you. Not for the class. For him.
Okay.
That's something I gave him. Yeah.
Okay.
All right. Any other question? Okay. Let me round up the class. Let me end the class now.